There's always a trade-off when you're doing drywall in the middle of the winter time, like now in January, and we want to be able to finish the taping process. So being an eco-friendly home, super energy efficient, it won't take much energy, but I hate to have them bring in their either kerosene-fired heaters or propane and put all that combustion air back into the building where we can turn on the heating system, whether it be permanent or temporarily, to supply heat to the structure. This project has several zones in it, and so it's always that trade-off. Do I do multiple circulators for each one of those zones, or do I do a single pump with all zone valves? In this case, I decided to do a mixture of things. For our high temperature, our air handlers, we have individual circulators that feed a specific air handler on here. So I have a dedicated high efficiency. In this case, we're using the VR1816. OOE series here that we can dial in and get the exact flow that we want on that particular device. And then over on the underfloor system, what we're going to do is have zoning on there. The same thing, I have a mixing valve down here to deliver a certain temperature. Like, imagine this one. This is probably the lowest temperature. This is in the basement and garage slab. But what we're going to do is we're going to attach like a header similar to this on top of here. So I have a circulator turn on, and then I'll have individual zones via zone valves for zoning those manifolds. So in this case, I would use a 2-zone over here because I have the garage and the basement over there. With our zone valves, we'll go into a zone valve control that will mount up here, and then it'll in turn tell everything else what to do. So that's kind of the advantage of doing these modules. You can see how nice and compact and neat. They're only 7 inches wide, each one. So every 7 inches, actually, I can do a different water temperature. So, being the basement and garage, being the lowest temperature, probably around 80-degree requirement, we're going to do radiant all on the first floor. We may have hardwood, tile, a little bit different floor finishes. So I may want to have 2 different water temperatures to fine-tune those. So same thing over here. There's areas that would have the maybe hardwood, might have a slightly higher water temperature than tile. I'll feed those manifolds that way and zone by that. Again, there's many different ways to look at this. I could create this one big manifold and put these little zone actuators or telestats on top and turn on and off each loop, where to me, I'm really zoning by an area. So in that area could be several loops, so I'll zone by manifold. So I'll come out of here, I'll feed like the manifold in the study, or I'll feed the manifold that's feeding the master bedroom, master closet, things like that, and be able to zone it all. But yet it's all compact, serviceable, and very clean looking. Like I said, it's a very small footprint for what we get on here. So really neat way or process to do this with our modular pump group type arrangements, and then we have our subzoning with zone valves. These little, modular pump groups are really sharp, and the idea, again, we said how tight they are and small footprint, but like in this case, I have 2 temperature gauge, red dial being the leaving water temperature, blue being the return coming back on there, so I can always see my delta T or temperatures going out to the system. They're actually ball valves. I can turn the flow off, so that's really neat. So now if I need to service or work on that or isolate something, I can, if I want to purge. So they're ball valves, and actually the return one right here, it has a check valve in that ball. So right now I have a check-way, a one-way valve that only allows flow, so if it's off I don't get gravity going up there. But if I have to drain a system and I want to take water out of that loop, I can actually turn it on a 45-degree angle so the valve is halfway open. And what it'll do is it will release that check valve, so now I can actually drain it down. So I have a choice of fully closed, fully open, or do I want to crack the check valve and drain the system on there? So quite unique on there. Like I say, very compact. Here happens to be a 3-way mixing valve on the bottom. We'll have an actuator on here that's going to drive that back and forth based on the requirements of the building. It could be weather compensation, or it could be indoor compensation. There's a couple different ways to look at it, but the whole idea is, have each one of these responding to the water temperatures required for that area. Yeah, we looked at the zoning modules there, but also what we have going on here, this is our primary pump. So basically this is pumping around the loop on my primary side or heat source side, going through each one of these. Now these things right here, we call it a distribution header. And the idea with that is that this can allow flow in each one of these modules when they turn on. But this one's kind of unique because what's built into here is right on the bottom is really a hydraulic separator. So I don't have to buy a separate hydraulic separator for a flow sensitive boiler. I just install this one device and now I will have flow through here whether I have zones on or off. So now the flow dependent heat source can be happy, and whatever the flow rates required out in the secondary or out in the building, they don't have to match each other. So it is really nice, and it takes up a lot less space than putting a separate hydraulic separator, piping up some kind of manifolding to hold your zone pumps or zone valves or whatever you're doing. So in this case, again, we have it all right here. It's all nice and neat. We'll just pop it right back on and away we go. So you can see how clean that installation is. It's got a little insulation block around it to do that, as with all the pump groups. So very clean and simple installation. Yeah, as with temporary around here, we have a well, but we actually physically put the well pump in yet. Again, you always wait to have heat in the building before you bring some of that stuff in. So what we've done is we actually hooked to a garden hose and grabbed some water from the neighbor's house over there. But we figured we'd do the whole process. And so what this is a unique little package here. This is a combination backflow preventer and PRV, or pressure reducing valve, all in one nice unit. It, again, very small, compact on here. It has a cartridge style serviceable element in there for this changing the pressure. Plus it has a dial and an indicator. I can spin this right here and set a specific temperature. Has a fast fill mechanism on it. I can do a fast fill. So it really works nice. So again, we had to take care of the few concerns, you know. Pressure reducing backflow. We also did an expansion tank on here, you know, size for the project, you know, so it's all tied into here, pressure relief, all the normal things you would look at in a heating system, even though it's not 100% complete. Now here's kind of the heart of the system. To me, it comes down to zoning. So to really make life easier, we use zoning panels. This happens to be a switching relay. So again, a low voltage thermostat on the top could enable line voltage circulators and still give me an enable or end switch to turn on a boiler or whatever the heat source would be on there. And to enable that, I can operate primary pumps. We can do a lot. This happens to be an expandable product. So when we say expandable, we have some dip switches and we have some timers built in. I can do pump exercise. It's like every 2 weeks of non-use, like in the summertime, I would run the pumps. I could do post-purge when the indirect is satisfied. There's a host of things we can do on this, or we can do multiple panels. In this case, I really only have 6 zone pumps. I, of course, have a primary pump, but 6 zone pumps, so the 6 zone panel will be fine. I wouldn't need to add on to there. What I'm going to do is put zone valve controls up here for those little headers we looked at there that will have the zone century zone valves on there, and we'll wire that into here to turn on the appropriate pump and start the heat source when it's required to do that. But again, it makes wiring so much easier to do these than to try to hand wire or make up your own thing or panels. So in this case, we'll bring them in, we'll wire them to each one of the zones, we'll bring in our power. We actually have a primary pump. There's a primary pump contact right here for our primary, so we're all set. And we even have a way to define when I want that primary pump to run. Do I want it to turn on with all zones or all the zones except for the priority zone, which typically be your domestic? You could pipe it off the boiler, or you could pipe off the primary secondary loop. So we have a choice. We can define how we want that primary pump to work. But again, simple, clean installation. Well, as you can see, you know, this is all the zoning and, pumps that we use to pump it around the building. But most of this is going to remain permanent. Like I said, we just tied in some temporary things, wires to here to get heat. But, we have to have something to generate this hot water that we're using and circulating through the building. So why don't you come with me and I'll show you what we have mounted for our heat source right now. What we're using for our heat source right now is the Sandin heat pump water heater. So we're actually using it as a heat source for the building off of here. What's unique about this is, first of all, it does not use regular hydrocarbons like, R410A or R22 or whatever you could think of, all these different refrigerants. This uses CO2 as the refrigerant inside of there. So very little ozone depleting. So, Of course, carbon dioxide can deplete, but very minimal. So it's not like 10 times or 20 times, as bad as some of the other equipment. The other unique thing about here is the high efficiency, or COP as we call it. This one has a COP of 4.5, which is phenomenal for air-sourced or air-to-water heat pump device on here. It is small output in this case, it is a 4.5 kW equivalent to heating. So yeah, so it takes us a while to bring our slab up, and that is super insulated. But once we get it up, it takes minimal energy to run. So this one's probably only drawing like maybe 7 amps or something like that versus a big compressor and everything else running on here. And it just silently purrs away and producing higher water temperature. The other thing about it, it can produce, this model can produce 149 degrees, and they have a newer version that'll probably get up to 160 or 165 degree water temperature. So you could almost heat a house ahead, baseboard or less efficient system. Yeah, we're going to keep this piece of equipment here for a backup heat source for our domestic hot water. We're going to have solar water heating as primary. We can have electric resistance backup, but why have that when you can have something that has a high COP? So we're going to leave this dedicated at that after we put in our permanent heating system in here that will be able to, supply the heat and the cooling, for the whole structure on here. So, it was not a waste of time. We put it in, but we're just kind of using it now only for heating of the building. So it's kind of a unique way to do it. It's dual purpose. We're set up for one thing, and they're going to actually end use as another. So it's really, project is evolving. You can see there's so many things going up on there. We'd really think you should watch and hang out and see how things happen here. It's really neat, as we move forward and complete this project.